So as I mentioned, we are going to break section 3.1 into two parts. So what we're looking here is part 2 on one of the other items. It's different. The first part, we were basically getting used to the idea of a function, using function notation, finding values, finding inputs, finding outputs, finding domain. But in this next part, we're actually going to do two separate items related to functions, and they're just important in their own right, as we will see as we move through our course. This first idea I playfully call function algebra. Basically, the idea is we're going to create a new function. Okay, and this would be along the lines of, how do I create a new number if I gave you two numbers, right? Let's say you have the numbers 5 and 3 in your hands, right? What are some ways that you can use 5 and 3 to create a new number, right? Well, you could add them, right? 5 plus 3 is 8. You could subtract them. 5 minus 3 is 2, right? You can multiply them, you can divide them, etc. So the same thing with the function. We're going to create a new function by either add, subtract, multiply, or divide given functions. Okay, so that is what I playfully call function algebra. So we're basically creating a new function by adding or subtracting or multiplying or dividing the ones that I have. And of course, then we can talk about domains and all that other good stuff. So for starters, though, here's the notation. What I have here to kind of get this in practice, I have 4 functions, right? The function f is defined as this quadratic. The function g is a line. The function h is a radical, right, square root, and the function r is a rational, okay? And when I want you to add them, remember this is a name, right? So I have a new function, and the name of the new function is called f plus g. What's this new function going to depend on? Well, it's going to depend on x. Of course, that's pretty simple, right? How am I going to create this new function? Well, I simply add the ones that I have together. But this is the notation that you will probably see in the textbook and in other math classes when they're trying to say, give two functions, add them together, right? So create the new function called f plus g. This new function will depend on x. In practice, you just basically take whatever f of x is and you add g of x. So coming up here, this is x squared minus 2x minus 3, and we're adding it to 3 minus 4x. So that's basically all we're doing. Combining like terms, it looks like we have x squared, a minus and a minus, minus 6x, and a negative 3 and a positive 3 gives us 0. So there is the new function whose name is f plus g. It was created by adding the two functions that I had. We added the function f to the function g, created a new function. And so that's basically it. All right, so pretty much combining like terms. Same thing here. Again, what's inside this set of parentheses is a function name, right? What's the name of this function? The name of the function is f minus g. What does this function depend on? It depends on x. So in practice, we're looking at f of x minus g of x. So take the two functions that I have. This is a quadratic, and we're subtracting the line. Of course, in this case, before we do anything, we're probably going to have to change the signs behind it, and we start adding. So it looks like we get x squared plus 2x minus 6. So there's our new function that we call f minus g. Of course, this new function is different than f, it's different than g, it's even different than f plus g. We've created an entire new function with a new graph, with new intercept, new domain possibly, all that other good stuff. All right, so that is what we do. We're creating new functions by adding or subtracting. It seems simple enough, but what's probably new to you guys is this crazy notation we use. All right, so again, what's outside of here is the function name, and here's what it depends on. So the next one, we have a new function, right, and it's called f times g. So what's this new function depend on? Depends on x. So basically, we're taking the f function and we are multiplying it to the g function. So that's how we're going to create a new function called f times g. And so in this case, we have this quadratic times this line, and we basically FOIL this out. So I think we get 3x squared minus 4x cubed minus 6x plus 8x squared minus 9, and it looks like a plus 12x. And so if we add everything together, we got a negative 4x cubed. There's an x squared and x squared. It looks like 11x squared. Got a negative 6x and a 12x, so that's a positive 6x. And then what's left over, it looks like we just have that negative 9 left over. So there's the function called f times g. And of course you would expect, right, the function f times g would be different than the function f minus g, which would be different than the function f plus g, which is different than the two functions that composed it. All right, so there you go. So that's when we multiply them. And then of course, last but not least, d, we're being asked to divide, right? I have a new function called g divided by f. So we create that, right, by just taking whatever my g of x function is and dividing it by my f of x. And in this case, we get 3 minus 4x all over x squared minus 2x minus 3. All right, and with the exception of simplifying, which we could try, right? So if we factor the bottom, yeah, there's no common factors anywhere. So there is the new function called g divided by f. Alrighty, and so there's much more to build on this, right? I'm already 6 minutes into this, got a few more to do, so why don't I cut away, right? And we'll continue to create a new function by adding functions, right? A new function called f plus g, subtracting a new function called f minus g, multiplying a new function called f times g, and then dividing functions, right? We've got a new function called g divided by f. So more coming later. We'll practice this with some more functions in a moment.